Hi everybody, welcome to the Manifold channel. We're going to continue our series comparing the workflow and speed of Manifold System Release 9 with workflow and speed in Esri's Arcmap plus Spatial Analyst. We're looking at $5,000 worth of software here in the Arcmap desktop. That's $2,750 for Arcmap Standard Edition, plus an additional $2,500 for Spatial Analyst, so you get all the nifty geoprocessing tools that provides. We're going to compute basins. Filling basins on this raster of Central Florida. That's 5,300 pixels by 5,300 pixels. That'll keep the amount of time that Arc spends geoprocessing to something that we can tolerate in a video. And we're going to see how long it takes a Manifold to do that as well. Here's the Manifold Release 9 desktop using exactly the same data set, and 5,300 by 5,300. We're looking at a software that costs less than $500, typically $450 to $495, depending on how you buy it on sale. And here's the project pane. Here's the Transform Toolbox. Transform Toolbox has got hundreds of tools. It's the equivalent of Esri's geoprocessing tool catalog. And I'm going to enter WA into the filter box to reduce it just to those transforms that I want, which is the watershed area sinks. What Esri calls basins, Manifold calls sinks. So let's fire that up. Let's click Add Component, and while it's running, it'll take 7 seconds. I'm going to open up the Task Manager so we can see that it's launched all 48 cores, all 48 threads on this 24-core Threadripper. And that's one reason why it only took 7 seconds to do all that. It's already done. And it created this sinks drawing, which is, first it did all the computations necessary, like flow direction and so forth. Then it did watersheds. Then it did the raster to polygon conversion to create these polygons right here. And these are all the watershed sink areas in Central Florida. Central Florida is a very flat place, so even in the Lake Wales Ridge region, you get a lot of these sinks that really don't drain anywhere. So that's the Manifold way. How long does it take Arc to do it? And let's get right to it, because it's going to take us a while. And we're going to start with flow direction, and the input raster we're going to choose is the Florida grid. Click OK. We're off to the races. Arc is running. It's doing its thing. The geoprocessing environment here, the parallel processing factor is 100%. So when it's running here, that's telling Arc to use as many threads as you think is reasonable. And in this case, it's launched 9 parallel instances. Now, given that we're running on a 24-core Threadripper that could be running 48 threads, why did Arc choose to use only 9 parallel instances? You know, it's not such a bad thing that it did that, because if Arc can't handle more parallel threads, you can actually go a lot slower. So, for example, if you do the same task in Towdem, which is an open source utility that's kind of famous for being parallel, Towdem will actually run on about 40 cores on this machine, but it doesn't parallelize very well, so those 40 cores, it's going to take it about 20 minutes to do what Arc does in about 4 minutes, or in this case, Basin's about flow direction about 1 minute 23 seconds, and Manifold does in like no time at all. We'll get into why it takes so long, primarily because what we're looking at here is a single-threaded application in Arcmap. It really has 2 threads. It can run the user interface, and it can run something in background, but it can't handle more threads than that. And what it does is it dispatches to these parallel modules here in the geoprocessing toolkit, some of which are parallel. Okay, we're in the completion phase, so we're coming to an end here. It's going to take 1 minute and 23 seconds to run flow direction. And then after that, it succeeded. Great, 1 minute and 22 seconds. Excellent. Let's keep going here, because this is Arc, so we don't want to waste any time. Our next task is to run Basin here in the hydrology. So I'm going to click on Basin. The flow direction raster I'm going to choose is the one I just created. Click OK, and we're off to the races again. So how many threads is the Basin going to use for that? In this case, Basin apparently is not parallelized. It apparently is going to use a single thread. So that's one reason why it's going to take a while. Basin takes 2 minutes and 27 seconds. This is very typical workflow for Arc. In order to compute what Manifold did in about 7 seconds, we have to do 3 steps in Spatial Analyst. First, we have to compute flow direction, which we did. That took 1 minute and 22 seconds. Then we compute Basin, which is going to take us somewhere around 2.5 minutes. And then after that, we do a raster to polygon, which is only going to take 20 seconds. So that's going to go relatively quickly. The composite step-by-step nature is something that is typical workflow for Spatial Analyst, where you do one computation that creates an intermediate result, that creates another computation that does an intermediate result, and so on. If all you want to do is basins, that of course is annoying. But it does have the value that if you're doing a variety of hydrology things, sometimes you can recycle that intermediate data sets. For example, a lot of the hydrology tools will use flow direction as one of their intermediate steps. If you've already burned 1 minute 23 seconds computing that, well, then it's not bad to be able to recycle that. In Manifold's case, of course, when it takes just a second or two to compute flow direction, that's not worth doing. It's not worth computing that unless you're working with a truly humongous raster that's like 2 gigabytes in size or something like that, say 50,000 by 50,000. The other reason why Esri does this is because the computations, especially if you parallelize them, get geometrically more complex as you do all these multiple steps. So by breaking it up into simpler steps, Esri can reduce the computation to what the architecture of the Arcmap and spatial analysis system can handle. Again, that's not stupid. That's simply being realistic about the limitations of the architecture. I don't mean to pan Arcmap, because I have a lot of respect for Arcmap, and Esri deserves to be justifiably proud, for the work they've done in parallelizing this stuff. That's one reason why we're comparing Manifold to Arcmap and not to something else. Okay, almost done here. Very soon. Yeah, why are we using Arcmap and not ArcGIS Pro? Well, the problem with ArcGIS Pro is that it keeps wanting to talk to ArcGIS Online. If you're an ArcGIS Pro user, you know that, how it kind of reaches out. And what we wanted to do is we wanted to avoid any effects where ArcGIS Pro is slowed down. Okay, succeeded. And that took 2 minutes and 26 seconds. And so let's do the final step, which is a raster and Polygon, which is only going to take about 18 seconds. And that's up here in the conversion tools. So there's raster to Polygon. And the input raster is going to be this base and flow that we computed. Leave everything else as is by default. And again, we're off to the races. This is the third and final step. And like I say, it's going to take about 18 seconds. Anyway, we're doing this in Arcmap because we didn't want to take any risk that ArcGIS Pro would be delayed by trying to connect to ArcGIS Online, going through internet, any of that stuff. And anyway, they're both exactly the same price. For $2,750, you get both. Okay, so we've succeeded here. And here we see the the same polygons. We're zooming here to the same region that we created in Manifold. In fact, we can format these. Let's style these so make these. Let's make the border 0.5 point, and let's pick a coloring for this that's kind of similar to what we used in Arc. That's not too wildly off. So you can see it's kind of a similar display, same computation. The difference is that Manifold just did it in a matter of seconds, not in 4 minutes. And what we're going to do here is some people will say, well, geez, it's kind of cool that you can do all this, but after all, as we did, we could have started here with the flow direction. Well, if you want to do that in Manifold, you can do that as well. First, let's create a flow direction intermediate step. We do that using a query, and that takes 2 seconds. You can see it take 2 seconds, whereas we took a minute and a half, and that creates this flow direction image. And now, based on the flow direction image, we can create a watershed area sinks using that flow direction image, using this query right here, where we're taking advantage of the flow direction image that we already created. And thread configuration is going to run all 48 threads. So to run that query, that's easy enough to do. We just right-click on it, and what do? We click Run. And you can see it's going to be really fast. It's going to be about 4 seconds, and there it goes, 48 threads running again. And the result was in 4 seconds, we shaved 2 seconds off the total amount of time. We created exactly the same drawing, the sinks drawing, as before, and that worked a lot. That worked slightly faster. Manifold's approach is not to do these multi-step intermediate things, because Manifold can handle the larger computations that are involved in simultaneously doing the within the same workflow to do the flow direction, the watersheds, and the raster to vector polygonization. Because when all this stuff is parallel, and we can take a look at this this query here, everything here you see here in this query is parallel. I mean, it's all running as many threads as you want, and because it's all parallel, the dispatcher that builds all the parallelization graphs, the query optimizer can optimize the stuff to run faster, because the optimizer knows that if ultimately, when we start with this flow direction image, we're also going to do a watersheds calculation, it can collapse a lot of steps in terms of the parallel workflow and reduce the graph to work more efficiently. That's one reason why Manifold runs can do all this stuff in 7 seconds, which takes Arc, a total of about 4 minutes. The other reason, of course, is that the parallelization intrinsically is faster and better. It took Manifold about 15 years of work to create parallelization at a level where instead of using 9 threads, it can use 48 threads. That's not easy to do, and if you look at even high-quality software like Taldem, which attempts to use as many threads as possible, when it tries to use 40 threads, those 40 threads step on each other. So doing this workflow in Taldem to create these basins, like I say, is going to take about 20 minutes. I'm not sure exactly, but it's profoundly longer than how long Arc can take it. And of course, it isn't remotely near the 7 seconds that Manifold does. That's one reason why a lot of vendors which attempted to do parallelization are stepping back from it a bit. There's one particular instance of a very high-quality company that's just announced they're no longer going to support parallelization because they don't know how to do it right. And there's no point in doing parallelization, which is slower than running single-threaded. So the final deal, of course, is that Manifold, besides being fully parallel, also uses a highly parallelized data storage as native data storage. Manifold.map format was designed from the ground up for basically being spatial work, parallel spatial work, and so it's very fast, it's very parallel friendly. In contrast, Arc here is using GDB, so all these intermediate results are going into GDB, they're being pulled from GDB, they're going through a single-threaded Arcmap and being sent to, somewhat, not terribly so, but somewhat parallelized external modules, and the result is it's slow. So for all the high quality things that you can commend Arcmap, for example, I just love how this metadata they provide. It's a wonderful readout. I think, to my mind, it's somewhat better than Manifold's log window. Manifold has a great log window, but this is better. There's a lot to commend in Arcmap, but without the parallelization, without that fundamental parallelization infrastructure, it's going to continue taking 2 or 3 minutes to do what Manifold takes 2 or 3 seconds. I hope you've enjoyed this video. We're going to continue the series with a variety of other comparisons. If you want to see how fast contours work and stuff like that, it'll just absolutely eye-popping performance difference between Manifold and Esri. And it's not just the sheer speed of the processing either. It's also the convenience of doing workflow in one click, where you have to do multiple steps here in Arc. That's also helps speed up the process in real life. So stay tuned for those videos. We see how those pan out. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.